Hello all. Today's video is with respect to the container orchestrator in a vehicle. So why are we even talking about an orchestrator in the first place? So if at all you see with respect to the zonal architecture, the idea is that you have one central controller or one central compute, maybe with the redundant compute as well, and you will have multiple zonal controllers connected to the central compute, and you will have the ECUs and sensors connected to this respective zonal controller, using which the data will be flowing around. Now most of the applications will be flexible in nature, so containers will be playing one of the critical part in the way the applications will be deployed. So we can mostly think about the QM applications, SLA and SLB. They mostly will be in the containers. That's the idea. So when that happens, you will have multiple containers going around, but in on the entire car. But there should be one central what to say node, which should be the master node, which controls or orchestrates the deployment of these applications, as well as seeing the status of this application as well. So that will be mostly done in the central controller. So you will be having, like, if at all, if you guys are aware with respect to the IT solutions, so Kubernetes is one such orchestrator where it orchestrates the deployment of pods or containers over multiple nodes. So the question over here is, why cannot we use the existing technology like Kubernetes inside a vehicle? So today's video is with respect to that. Now let's get into the details of Kubernetes. Now Kubernetes is quite popular, but it has a lot of drawbacks with respect to the automotive use case point of view. So the first drawback is the eventual consistency. So what does eventual consistency mean? So eventually consistency means that if at all I want something to be done, it will be done, but you cannot say in which order it will be done and how soon it can be done. Like how it is used in Kubernetes, like there is a website and there is a Black Friday sale going on, and multiple people are trying to reach the website, and slowly the infra in the backend scales, and based on that you will be able to access the website. You may have a delay, but you will mostly be able to access the website, and you can just log in and do whatever you want. But you cannot expect the same thing to happen in a car. Like when you say the car is going at maybe 100 kilometers per hour and you steer the car right, you expect the car to turn right. The orchestrator cannot say that, okay, fine, I will turn right, but it will take some time, or I will execute something else and I will do it. That will not work out. It will end up in a fatal accident. So that is one issue with respect to Kubernetes. Second issue with respect to Kubernetes is the uptime. Like if at all you want a container to be spawned right now, it will not instantaneously spawn. It will take its own amount of time, which is okay for the regular IT solutions, but it will not work out for solutions, especially in automotive space. That is the second use case. Third use case means, sorry, the third drawback. Third drawback is the excessive resource utilization. Like Kubernetes is actually built for large distributed systems where compute is lack of compute is not such or not of such of a high priority. So in that case, basically what happens in Kubernetes is like you will have lot of unnecessary functionalities which are not necessary for a automotive use case. Now, but that still will be running along. Because of that, what happens is, if at all, say this was a test which was actually done. So if at all you have a Raspberry Pi 4, and if you want to run Kubernetes in it, 15 to 20% of the compute available is taken only by the orchestrator Kubernetes. I'm not even counting with respect to the container runtime, only the orchestrator. It consumes 15 to 20% just by doing nothing. So this particular thing will not work out in the automotive use case. And coming for the fourth point, like as I said earlier, Kubernetes is basically designed for large distributed systems, which is actually an overkill for our automotive system, which does not need something as complex as Kubernetes running on it. And the fifth point is with respect to the Go programming language. So most of the cloud technologies are mostly written in Go. The reason why this will not work out well is you are talking about an automotive system where the garbage collection mechanism, that is basically an issue over here. The low level access to the low level hardware access is another issue. The deterministic timing, that is with respect to the how real time the system is, that is a problem. And how does the existing C++ libraries get what to say can be interacted with the Go programming language is another issue. And apart from that, the entire tool chain and debugging mechanisms, which are already well established for C++, how do you port that to Go? So that is basically another big issue, because of which you really cannot do the functional safety certifications and all. And on top of it, you will have this failure handling mechanism. So in Kubernetes or such orchestrators, basically what happens is, if a particular application is down, Kubernetes will somehow try to make that application run once again, and it will strive for that. But in reality, this should not happen in a car. Like, say one application, maybe an SLA or SLB application is down for some reason, immediately a trigger should go to the passenger, or to the driver, saying that hey buddy, the system is so and so application is down for some reason, I don't know why, I want you to take control of the car, now don't trust me. So this kind of mechanism is something which is not incorporated in Kubernetes. So that is the reason why Kubernetes was, or another versions of the Kubernetes like K3s or K0s or anything, cannot be directly used, or they are not the right technology to be used in the automotive sector or the automotive domain. So what are the current requirements which we have? We want a deterministic behavior. So what do you mean by deterministic behavior? Deterministic behavior means that the orchestrator should know that what container is running, where it is running, and since when it is running. So the orchestrator should have the deterministic behavior, and it should clearly know what is running, where it is running, and when it is running, since when it is running. Second one is a smaller footprint. So you cannot expect an orchestrator to consume 15-20% of the resources. That will not work out. That is another thing. The third point is the shorter uptime for any application. Like, if at all any application has to run in automotive space, it has to be up as quickly as possible, unlike Kubernetes or its derivatives versions. And the fourth thing is you need to write the orchestrator in a programming language which is kind of heavily used in automotive space, like C, C++, or recently Rust. So if at all you use any of these, then that is much more beneficial, and that is much more adaptable for the automotive use case. Now, while we know that this is the problem of the existing Kubernetes and this is what we want, so who are working on it? Now, if at all you see, there are two contenders over here. As far as I know, there may be more, but this is what I know. So there is Bluchi from Red Hat. So Red Hat has an operating system by name AutoSD, where they have given Bluchi, which is basically a mixed criticality orchestrator, which is written, I think, in C or C++. And similarly, there is NKOS, which is from Electrobit, which is also an orchestrator from Electrobit. So in the further videos, I will have a deep down into these particular orchestrators, and I will bring you more information regarding this. Thank you for your time. Thank you all. Bye.